Happy Thursday, everybody. Today we're going to continue learning about the Pythagorean theorem, and this time we're going to look at the legs of the right triangle. So far, we have just been looking at the hypotenuse, and all of you have done really well with that. I am impressed. You are a very impressive group of students this year, and I really appreciate your hard work and your dedication, especially in this online learning environment. So, having said all of that, let's start with just the basic review of the Pythagorean theorem, which tells us that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So remember that the Pythagorean theorem only applies to right triangles, and it's the a squared plus b squared equals c squared. And as we look at the characteristics of the right triangle, we've already learned that side C right over here is the hypotenuse. All right, we've spent the past 2 days learning that. So today, we're going to learn the characteristics of the legs and how to find the length of the missing leg. So the first thing we want to notice about the legs, which are sides A and B, is that they form the right angle. So the right angle is what makes a right triangle a right triangle. The fact that it has the right angle that equals 90 degrees, and it's the legs that form the right angle. Additionally, because the legs form a right angle, they are also perpendicular. All right, perpendicular are two lines that form a right angle or 90 degrees. And then the last thing that we want to notice is that they also form in L. So this is one way that you can avoid confusion between what is the hypotenuse and what are the legs, is if you follow the cursor, you can go down and to the right, and those legs always make the L of the right triangle. All right, so that's three characteristics that should help to keep you from getting confused or mixed up about the differences between the legs and the hypotenuse. So what we want to do today is use the Pythagorean theorem to find the length of the missing leg. All right, so here we go. Go ahead and get your paper and pencil ready, and make sure that you turn all this in today with your assignment, and we're going to start learning how to find the length of a missing leg. All right then, so in our first right triangle, we have side A, which is unknown. Then we have a length of a leg that's 8, and the length of my hypotenuse is 10. So I want to solve for the missing side. So I'm going to use my a squared plus b squared equals c squared. Now, my side A is the side that I'm looking for. So I'm just going to leave a squared as it is. So b squared is going to be 8. I'll substitute the value of 8 in for b. And then the hypotenuse is always c. So that's going to be 10 squared. All right, so just like yesterday and the day before, when I'm looking for my hypotenuse, I would square them and then add them and then find the square root. Today I'm going to square the sides. So 8 times 8 is 64. That's not 8 times 2, that's 8 times 8. And then 10 times 10 is 100. So I'm going to square the sides. Then what is different today is I am now going to subtract the sides. Because if you notice here, you have a squared plus 64 equals 100. And if I'm trying to isolate my variable, I'm going to do my inverse operation. So what is the opposite of addition? It is subtraction. So that gives me a squared equals 100 minus 64, which is 36. And the next thing I'm going to do is take the square root, which is going to cancel out the exponent because that is an inverse operation. And then I'm going to take the square root of 36. And I know that since 36 is one of my perfect squares, 6 times 6 is 36, so A equals 6. So the lengths of my sides for this right triangle are going to be 6, 8, and 10. And you'll notice as well that my hypotenuse, 10, is the longest side. All right, so let's do the other example together. So I have the right triangle, and this time I have 10, I have B, and then I have 26. And I'm going to be looking for the length of side B. So I start again with my A squared plus B squared equals C squared. So this time I know A. So I'm going to substitute 10 for A. And then my hypotenuse is 26, so I'm going to substitute that for C. So now same thing as I square them. So 10 times 10 is 100. 10 squared means 10 times 10, not 10 times 2. So 10 squared plus B squared equals, now I don't know 26 squared, so I'm going to come over here to my calculator and do 26 and just hit the X squared key. And that gives me 676. So then I'll come right over here, back to where I was. So 100 plus B squared equals 676. So now I subtract 100 from both sides because everything's about inverse operations when we're doing equations. So now I have B squared equals 676 minus 100 is 576. Then I take the square root of both sides. So I'll go back to my calculator here. Second function key, X squared key. And my answer is 24. So B equals 24. And again, you'll notice that my hypotenuse is 26, and that is the length of the longest side. So let's do the third example. So again, I have my right triangle, and I have A, B, and then side C is 50. So A squared plus B squared equals C squared. So I have A squared, since that's the side I'm looking for. My B side is 14. And then C is going to be 50 squared. So let me go to my calculator and do 14 and hit my X squared key. And that gives me 196. And then 50 squared is 2,500. All right, so I have A squared plus 196 equals 2,500. So now I'm going to subtract 196 from both sides. So that gives me 2,304. Now I find the square root of both sides. Those cancel out. Where did that come from? And that gives me an answer of 48. So A equals 48. And again, you'll notice that your hypotenuse C is your longest side of 50. Okay, so that's all there is to finding a leg. There are some practice problems for you to do up on Google Classroom, and I will be up on Google Meet, and you can certainly email me or meet me on Google Meet if you have any questions. Thank you so much for your attentiveness and for being such an impressive group of people. I look forward to what we will be doing tomorrow and the rest of next week. All right, have a great day. Thank you, everybody.